Two lines are said to be parallel if they run adjacent to each other, i.e. they run next to each other in the same direction and are always the same distance apart. They never get any closer and they never get any further away. They are always exactly the same distance apart. Because of that, parallel lines will never meet. If they never get any closer and never get any further away, nowhere along their length will they ever meet. If you need something to think about from real life, think train tracks. Train tracks have to be parallel. They have to always be the same distance apart from each other. If two lines aren't parallel, then it is possible that they might be perpendicular, which is a fancy way of saying they meet at 90 degrees. So two lines are perpendicular if they meet at 90 degrees. And each of these has a particular symbol. For perpendicular lines, we can show that they are perpendicular by drawing in the right angle box. For parallel lines, we might use an arrowhead to show that the two lines are parallel. And we need to be aware of both of those pieces of notation. The right angle box to show that two things are perpendicular and what the word perpendicular means, and the arrowhead to show that two lines are parallel and what the word parallel means, because they're the kind of words that will turn up in questions and we'd be expected to know their meaning. A line of symmetry is a straight line that cuts a shape into two pieces that are equally sized and mirror images of each other. For example, if we have a look at these two shapes, if we look at the blue arrow first of all, I could draw a horizontal line through the middle of that shape like this. Lines of symmetry are often shown as dotted lines, and this dotted line splits the shape into two pieces, one above the line, one below the line, that are equally sized and are mirror images of each other. If we look at the green shape now, I could draw this particular line in from top to bottom that again gives us two pieces that are equally sized and mirrored. It is not enough that the pieces are equally sized. They have to also be mirror images of each other. Otherwise, it is not a line of symmetry.
So we've just seen what symmetry and lines of symmetry are, but there is another connected thing that we also need to be aware of, and that is called rotational symmetry. Now, rotational symmetry is loosely connected to the idea of symmetry, but they are in fact completely different things. Whenever we see mention of rotational symmetry, or we are asked to give the order of rotational symmetry of a shape, then what we do is we grab our tracing paper. Now, you are allowed to have tracing paper in the exam. You are not allowed to take your own in. You will have to ask for some, but you will be allowed to ask for tracing paper, and you can use tracing paper for whatever you like. In particular, though, we should be using tracing paper for this question. And this question would go, write down the order of rotational symmetry of the following shape. So we look at this particular shape. It doesn't matter what the shape is, we're always going to do these questions in the same way. And step one is to place the tracing paper over the top of the shape and trace it. We don't need to be too accurate or too neat with this, but we do need to trace the shape fairly quickly, reasonably neatly. And there we go. Now I'm not going to do anything with that, I'm just going to trace that shape. And I'm not going to move my tracing paper, I'm going to leave it there. Step number two, I'm going to mark one of the corners. It doesn't matter which corner I mark, but I'm always going to mark the same one, and I'm always going to mark this one up here with a dot. Because what I'm going to do is I'm going to move this tracing paper now. I'm going to move it in a very particular way, but I'm going to move it. And I will know that it's got back to where it started when that dot returns to where it is now, the top right corner. So if you always mark the same corner in the same way, you'll always know when you're back to where you started. What I'm now going to do is I'm going to get my pencil, and with my pencil I'm going to place it in the middle of the shape, over the top of the tracing paper. So I'm placing it there in the middle of the shape to make a pivot, effectively. And I am now going to rotate the tracing paper. Not the page, but the tracing paper. And I am going to count every time that that shape fits over itself exactly between starting to rotate and it returning to where it was when we began. So here we go, I'm going to rotate it a full turn. And there's once. Allowing for the fact that I wasn't quite in the middle, there is once when the shape is upside down. And there is twice when it's back to where it started. So once when it was upside down, twice when it gets back to where it started. And then we say that this shape has rotational symmetry order 2, which is a fancy way of saying if we turn it a full turn from the middle of the shape, using the middle as a pivot, we turn it through a full turn, it fits over itself exactly twice before it gets back to where it started. Once when it's upside down, once when it's back to where it started. Write down the order of rotational symmetry for the following shape. So we've got a star this time, but we can still do rotational symmetry in the same way. We grab our tracing paper, and we place it over the top of the shape. We then trace the shape, and I'm going to mark one of the corners, any of the corners, as long as I remember which one it is that we've marked, so that we know when we get back to where we started. I'm going to mark the top corner because it seems like the most logical choice here. I'm then going to find what's roughly the middle of the shape. I reckon it's about there, and I'm going to use my pencil as a pivot. I'm going to hold the pencil on top of the tracing paper to use as a pivot. I'm going to rotate the shape, and I'm going to count how many times it fits over itself. So there's 1, 2, 3, 4, 5, and it's back where it started. I have to count the one where it is back where it started, but that is 5 times, which means the shape has rotational symmetry order 5.